Okay, here we are with lesson 22, solving equations using algebra. This is going to be a two-part topic. First topic being lesson 22, and then we're going to finish up our unit with lesson 23 and solving equations using algebra part 2. So let's start with example 1. On your lesson worksheet, read the problem regarding Yoshiro's new puppy. We're going to answer several questions using this problem. First of all, we're going to start with the first one. What is the general shape of the puppy yard? When shapes or figures are described, it is very helpful to draw a picture. Let's draw a sketch of the puppy yard. Based on the description given, you should have something that looks similar to this, where we have the two sides that we don't know, labeled as n. We know that this side is 10, this is 12, this is 15, and this is 20. All right, for question 2, write an equation that would model finding the perimeter of the puppy yard. The sum of the lengths of the sides is equal to the perimeter. You should have something that looks like this. N plus n plus 10 plus 12 plus 20 plus 15, and the whole thing equals 137. So question 3, model and solve this equation with a tape diagram. Well, with a tape diagram, we would have n plus 20 plus 15 plus 12 plus 10. Obviously, these can be in any order. But we do know that the numbers, we can add those up and come up with a sum of 57. From that, if we know the whole yard or the whole perimeter is 137, we can subtract that 57 to get 80, which is going to represent the two unknowns that we have here. Since there's two of them, 80 divided by 2 is going to equal 40. So therefore, n is going to equal 40. So let's review how to make 0 in an equation or subtraction equation. So starting with b plus 4/5 equals 1 and 8/15. Again, if you want to write this in your math journal as just a review, if you find out after going through this you have forgotten this, you will definitely want to write this down. But when we want to isolate b and make it equal to a constant on the other side of the equal sign, then if we have plus 4/5, we want to subtract 4/5. If we do that on both sides, which then gives us b equals 0 plus 1 and 8/15 minus 4/5. And then what we would do is solve. B is going to be equal to whatever this is simplified, which after you do all the math, you end up with 11/15. Now, how do we know that this is a true statement? Well, if we start with our original and plug in or substitute 11/15 for b, then as we simplify the left side of the equation, that would be 11/15 plus 4/5 is equal to 1 and 8/15. Well, that's the same as the right side of the equation, so therefore it is same. So this is what we call the subtraction property of equality. If we subtract a value from both sides of the equation sign, then that keeps our expressions the same or equal to each other. All right, let's take a look at with decimals, and instead of subtracting, we are adding 4.5 to both sides. Again, our goal is to isolate b so that we know what value b is equal to. When we do this, again, we get 0. Then b is equal to this expression, which we can simplify, and we get b is equal to 6.315. How do we know that this is true? Start with our original equation, substitute 6.315 for b, and then simplify the left side of the equation. When we simplify this, we get 1.815, and that is the same as the right side of the equation. So what this is the addition property of equality. We can add a value, the same value, to both sides of the equal sign, and it doesn't change the balance of one expression to the other. All right, let's review how to make 1 in a multiplication or division equation. Well, if we have the equation 1/3 of t is equal to 18.15, then again, in order to make a 1 times t, because that's our identity property, we would divide 1/3 by 1/3. Again, if we do that to one side of the equation, we have to do that to the other side of the equation. So therefore, 1/3 over 1/3 is 1, which again becomes invisible. And so all we have to do is solve 18.15 divided by 1/3. And when we do that, we get 54 and 45 hundredths. Notice how the 1 disappeared from this step to this step. All right, how do we know that this is true? Again, substitute 54 and 45 hundredths for t. 1/3 of 54/45 is simplified, and it becomes 18 and 15 hundredths, which is the same as the right side of our equation. This is called the division property of equality. If I divide one side of the equation by a value, I have to divide the other side by that same value. All right, last but not least, let's say we have a division problem. T divided by 1 6/10 equals 5 4/7. Well, now, in order to get t to be 1, or 1t, to undo the division, we multiply by 1.6. If we do that to one side of the equation, we do it to the other. So 1t is equal to 5 4/7 times 1/6. The 1 disappears again because it is invisible, it is implied. And so all we have to do is simplify 5 4/7 times 1/6, which in this case is 8 and 32/35. And last but not least, to plug this in for t, we would substitute it in and then simplify. What is 8 and 32/35 divided by 1 6/10? And you find that it is 5 4/7, which is the same as the right side of the equation. And this is called the multiplication property of equality. All right, so now that we have reviewed all the properties of equality, now we can go to question 4. Use algebra to solve this equation. First, use the additive inverse to make 0 to find out what the lengths of the two missing sides are together. Then use multiplicative inverse to make 1 to find the length of one side of the two equal sides. So if 2n plus 57 is equal to 137, then we can say that 2n plus 57 minus 57 is equal to 137 minus 57. That is the subtraction property of equality. So if that's the case, if 2n plus 0 equals 80, then 2n is equal to 80. This is our additive identity. If we add 0 to a value, it doesn't change that value, it's the same thing. So then our next if 2n is equal to 80, then 1/2 of 2n is equal to 1/2 of 80. Can you guess what property that's going to be? If you said multiplication property of equality, you are correct. Then last, if 1n is equal to 40, then that means n is equal to 40, and that is our identity property of multiplication, or multiplicative identity. All right, question 5. Does your solution make sense in this context, and why? Well, yes, 40 feet would make sense because when you replace the two missing sides of the hexagon with 40 in the number sentence, 40 plus 40 plus 10 plus 12 plus 20 plus 15 is equal to 137. The lengths of the sides reach a total of 137. So 137 is equal to 137. All right, let's take a look at example 2. Read the problem about Jimmy's swim practice. Or Jenny's, sorry. Question 1, write an algebraic equation to model this problem and draw a tape diagram to model this problem. So we're going to let x equal the number of hours of swimming each morning. Now you can assign a different variable if you want, but again, this is an important statement. You should have a statement starting with let to identify what variable you're using to equal the number of hours of swimming for each morning. So if we model the days of the week, days per week, our next part can be modeled, number of hours swimming AM and PM is going to be equal to the hours of swimming total. So days per week would be 4. The number of hours swimming both in the morning and the afternoon, since we don't know the morning, that's x, and we do know the afternoon, so that's plus 2. And then the total hours of swimming would be 12. So here is our algebraic equation. So question 2, solving the equations algebraically and graphically with the help of a tape diagram. So our tape diagram should look similar to this. We should have 4 boxes, each with x plus 2 in them, and the whole thing equals 12. So if we're going to do this numerically, 12 minus 8, because we have 2, 4, 6, 8, is equal to 4, and 4 divided by 4 is 1. So Jenny is swimming 1 hour each morning. So algebraically, this would look like if 4 times the quantity of x plus 2, because we have 4 boxes with x plus 2 in them, and that's equal to 12, then that means I can multiply both of these sides by 1/4 so that we can get rid of the 4 times. So 1/4 of 4 times the quantity of x plus 2 is equal to 1/4 of 12. Well, that is our multiplicative property of equality using the multiplicative inverse of 4, because the inverse of 4 is 1/4. So if that's the case, if 1 is equal to x, or 1 times the quantity of x plus 2 is equal to 3, because 1/3 or 1/4 of 12 is 3, that is using multiplicative identity, we can just drop the 1. That means then x plus 2 equals 3. And last, if x plus 2 equals 3, then by using the subtraction property of equality and using the additive inverse of 2, which is -2, then x plus -2 equals 3 minus 2, or plus a -2. And last but not least, that gives us if x is equal to or x plus 0 is equal to 1. That is our additive identity, which means then that x is equal to 1. So question 3, does your solution make sense in this context and why? Well, yes, if Jenny swims 1 hour in the morning and 2 hours in the evening for a total of 3 hours per day, and she swims 4 days per week, well then 3 times 4 is 12 hours for the entire week. All right, now it's your turn. You're going to try exercises 1 through 5. You're going to solve each equation algebraically using if-then statements and stating the property to justify each step, just like in the examples. Make sure you check your answer after each problem. So after each problem, stop, check your answer, make any additions you need to, and then start the next problem. All right, you should have exercise 1 completed. And here is the answer to exercise 1. Remember, for this lesson, we are doing if-then statements throughout the whole process, so make sure you include those. And then again, after each if-then statement, you have a property that you are identifying as to what process you are doing. All right, number 2 should be done. So here is the answer to number 2. Again, if-then statements and stating the property after each then statement. Okay, number 3. You have a word problem about Claire's mom. And here is the answer. Now, if you had x divided by 2, that's completely fine. Again, if-then statements, and you should have 4 properties to show what you are doing. Now, if you did division property of equality instead of multiplication property, that is completely fine and acceptable. Okay, number 4. Using your if-thens again, and you should have 4 properties of equality listed. And number 5, you have Ben's family leaving for vacation, and here is the answer. Again, stating, now if you did this where you multiplied 60m plus 60m plus 240, you could do it that way. Just make sure you're stating distributive property and then whatever other properties you're using. But you should get to m is equal to 6. All right. So what do we mean when we say solve the equation? What property allows us to add 8 to both sides? What role does the additive inverse play in solving this equation, and how can you model its use with a tape diagram? And what role does the multiplicative inverse play in solving this equation, and how can you model its use with a tape diagram? And what does this equation look like when modeled using a tape diagram? Basically, we work backwards to solve an algebraic equation. For example, to find the value of a variable in the equation 6 times x minus 8 equals 40, we use the addition property of equality to add the opposite of negative 8 to each side of the equation to arrive at 6x minus 8 plus 8 equals 40 plus 8. Using the additive inverse property to show that negative 8 plus 8 is equal to 0, so therefore 6x plus 0 equals 48. Use the additive identity property to arrive at 6x equals 48. And then use the multiplicative property of equality to multiply both sides of the equation by 1/6 to get 1/6 of 6x is equal to 1/6 of 48. Again, you could switch this out with the division property and say that you are dividing by 6. And then last but not least, use the multiplicative inverse property to show that 1/6 of 6 is 1, and also 1x equals 8. So therefore, the multiplicative identity property lets us arrive at x equals 8. All right, we'll see you in class.